sorry to interrupt everyone. I mean, it's great that it's so noisy in the room. That's kind of the point. So we feel kind of embarrassed stopping you. But yeah, we want to move on to the next of presentation slots, which is about the some of the platform features, some of the platform roadmap, and give you a bit of insight into some of the technology behind all this. So I'd like to introduce you to Emilio and Bogdan, who are going to talk about the software platform and components on that platform. I think we'll take a couple of questions at the end. But yeah, over to Emilio.
Right. So we wanted to present you some of the advantages of adopting the mbed platform that has been completely open sourced about 8 months ago. The first thing that people notice approaching the platform is the modern and the user-friendly object-oriented API that it provides to the final users, the developers. From the perspective of our partners, silicon vendors or component vendors that are starting to consider if to enter in the embedded ecosystem, the main true advantages are, of course, from the perspective of the component vendors, the fact that they will have to implement a driver library only once on the embedded API, and that usually doesn't require to access the MCU registers. And that's, of course, allow the driver library to be supported automatically in all the embedded platforms without having to repeat the effort multiple times. And instead, from the silicon vendor perspective, of course, the effort is only to implement the embedded hardware abstraction layer once, and it automatically the platform that is trying to enable will get the benefit of receiving all these multitude of components that are starting to appear on the embedded website. And of course, to make that practical from a professional point of view, we are starting to focus on many other details, like taking care of the licenses, the contribution agreements, and how everything get a consistent approach and process. For the people in the audience that are not familiar with how it looks, the embedded API, on the left you can see a very, very simple example, and it's actually difficult to find something more complex because usually from the developer point of view, the API is always focused on the actual functionality, and that tends to be quite simple if well thought and architecture. And on the right, instead, you can see the implementation of such API, and again, our focus is enabling these component vendors to implement it without accessing the underlying MCU registers. Another highlight is, of course, all of that now is supported on a multitude of platforms, and that is growing quite rapidly, especially after the open sourcing of the project. And it is supported on a multitude of tool chains, and especially we can also export to fine engines. And actually now I'm going to pass the presentation to my colleague Bogdan, that is going to highlight certain technical features of the platform.
Okay, I hope this is working. Okay, so let's take a bit of look at the code and understand what mbed is all about. From a code standpoint architecture, you're going to find two things in the mbed. Code that is platform dependent and code that is platform independent. In this diagram, code that is platform independent, it's the one at the bottom that says targets, and everything about the target interface, the blue box, it's platform code, which is actually generic code. It doesn't depend on a target. So obviously you want to do two things here. One of them is to have your target code as small as possible, as concise as possible. And the other one is to have your platform code written as generic as possible, so you can use it and reuse it on another target without changing a single line of code. And another very important thing here is that the HAL, the target interface, the HAL is our, basically, it's what the target needs to implement in order to make it compatible with the mbed SDK. That is a C interface. It's not guaranteed to be stable. It might change unexpectedly. Everything you see in the platform code, especially the peripheral API, which is written directly on top of the target interface, has an API that is guaranteed to be stable. It's backwards compatible. So every time you write an application, or really every time you write a library, and just when you want to implement a component, not necessarily a library, you want to be sure that you make it as platform independent as possible, and don't skip a level. Don't go directly to the implementation at the bottom. Try to implement everything as generic as possible by not looking into your microcontroller details. And of course, on top of that, on course of the peripheral API, our libraries such as RTOS, network, USB, and our many components, I've just listed a few there, you're going to write your applications. So what that means for you, as someone that wants to have your target or your board compatible with the mbed SDK, is that you're just going to have to implement that little layer there on the bottom. And then, as an added bonus, you're going to have all the generic code that's up there in the platform code box available for you. That's basically for free. You don't have to write anything there. It automatically becomes available for you, which is of course a very good thing for your target and for the people that are trying to use your target. Now I'm just going to do a very brief overview of how a port looks like. I've chosen the LPC 11U24 as an example. So what you're going to have to do on the left side, you're going to have to import the SlimSys layer, and on top of that put a few things such as your linker command file and the startup code, which are of course target dependent. And on the right side, you see how the actual HAL implementation look like. So you have a pretty small set of header files and C source code that implement our HAL. I'm not going to go into much more detail now because it doesn't make sense. Two important things here. One, you don't have to implement everything in one step when it comes to the HAL. You can start small, you can start with simple drivers such as GPIO, UART, and when you have UART, bang, automatically you have printf. You can write the rest of the code much easier. So you can take this incremental approach, test in between and so on. And the other very good news is that there is a lot of reference code for you out there. You can look at it. You don't have to start from scratch. You rarely have to start from scratch. Again, I'm not going to insist. If you're curious, just take a look at it, and you might find that it's easier than it is to implement this SDK. And I think I've mentioned, that our generic code, the big box with all kinds of cool stuff in it, it's written in C++. And what we found out is that when people learn that our SDK is written in C++, they are automatically afraid that having C++ on such small targets is going to be a huge overhead. In fact, a few years ago, long before joining the art team, when I first learned about the mbed SDK, and I saw that it's written in C++, my first reaction was, hell no. My second reaction was to close the browser tab and do something else, because I thought it was impossible to do that correctly. But it turns out that there is a way to make C++ usable on small targets. And to do that, first of all, we try to avoid C++ mechanisms that are considered to be very expensive, such as exceptions or real-time type information. We're using templates just very lightly, and for things like allocating data structures as compile time instead of runtime, because that reduces our overhead. Then again, by using C++, you can have some very interesting things happening in your code. As Emilio already showed you, sorry, let me go back a bit. The example here. C++ is what enables this component-based approach. So you see that you can just declare an accelerometer and an LED, a set of LEDs. You don't care what happens behind. And that's because C++ is doing encapsulation. And this is actually a huge deal in the way you can design and then implement your code. It's very concise, it's exactly what you need, you don't need to care about the details. And the other part, of course, is polymorphism and inheritance and having interfaces. I'm going to go back to that in a minute. To have an idea about how lightweight it actually is, it actually runs on that little thing on the right, which is an 8-pin Cortex M0 microcontroller with 4K of flash and 1K of RAM. You can actually write quite a few applications on that one, so you can imagine that the overhead is not that much. And we also made a small test with the speed. It's a test that is often used in embedded systems. It's just something that tries to toggle an output pin as fast as possible, and then you hook a logical analyzer or an oscilloscope on that pin and try to see what kind of waveform you get. So on the left, you have the version written with the C++ API, and on the right, you have the C version written on top of HAL. And on the bottom, I don't know if it's very visible, I hook my logical analyzer to in each of these cases, and I got a steady 3 MHz on each of them without any differences. My logical analyzer that I think was sampling about 24 MHz or something like that, was not able to see any difference. So, okay, it is a trivial example, but it does illustrate the point. C++ doesn't have to be huge. And now, coming back a bit to the other cool stuff, well, one of the other cool stuff about C++, you can use object-oriented design principles to make your code look a lot better. So, what I depicted here in the blue box, it's our socket interface. That's what we use to write network-enabled TCP/IP applications. So on top of that, you can implement other protocols. For example, HTTP client, WebSockets client, NTP client. By the way, these are all part of the mbed framework. And on top of that, or just on top of the socket interface, if you don't need any additional protocols, you can write your own application. And because it is a C++ interface, basically, it's very easy to change your physical transport. So you can go from wired Ethernet to Wi-Fi to GSM or CDMA modems, and many times it's changed just, you include a different header file and then you instantiate a different object. So it's as easy as it gets. And now I'm going to let Emilio talk a bit more about this.
I'm gonna just add a few informations about what we are planning to do in the following months and what is coming on the mbed platform. And one of the important additions that you are going to see is that we will start to support new wireless generic APIs, and you will see this afternoon different examples of that. Particularly one of the first that is coming is Bluetooth Low Energy. Kevin will talk about that. And also, as part of that, we will provide reference hardware implementations. And one of our focus that will be expanded by my colleague Chris is that we will try also to provide schematics and building blocks that then can be the basis for creating new projects, new products. And if all of that is respected, all the code of the embedded platform will be guaranteed to work on the final product that should go into production. The other highlight is how we are gonna actually integrate all the different components that will be developed on the embedded platform. So what we call components can be obviously an hardware peripheral, and there are many examples of that. But we are starting to have also these services building blocks. So typical examples of that could be nanoservice, the XIV library, and many more will come. This is a bit of an overview of how basically our core library started getting momentum from when we open sourced it 8 months ago. You can see the number listed here, and by the way, if you are not already part of our embed dev mailing list, consider subscribing to it. There are interesting conversations going on, and now that we also open sourced the interface firmware for our developing boards, we think more and more interesting conversations will start to be triggered in that forum, in that mailing list. But the most interesting new approach in the following months for us will be how we are going to guarantee that there is a core set of components that are respecting, are in synergy with all the other embed libraries, are respecting our approach on open license that is friendly for the development products, like the Apache version 2. And so we are starting to plan to organize a process similarly to what is done in the Apache Software Foundation for incubating projects into the embedded official libraries. And as part of that, we will take care that every contributor to the library has actually signed the contributor agreement. And it is aligned with the other embedded libraries, and it is a library that is considered useful by the rest of the community. Another big highlight of what we are going to focus on in the following month is the test infrastructure. And again, we are going to do that taking full advantage of our online infrastructure. And so the current test infrastructure we have will be scaled up, but especially it will be made available to the rest of the community. And what we really want to focus on is actually improving the culture among our community to start considering test-driven development, unit testing, and continuous integration as a standard part of their development. And now I'm going to pass.
Okay, so the reason you have me back here is that this slide has a bit of a personal touch for me. Besides working for mbed, I'm also the author of Ilua. That is a project which aims to make embedded development easier by having the Lua language run directly on your microcontroller. So basically you just connect to your target through an IDE or through a serial port, and you can write the code directly there, and you can experiment and do all kinds of nice stuff. And while writing Ilua, which by the way, one of the goals is to run on as much microcontrollers as possible. That was one of the initial design goals. I was trying a lot to focus on making the project itself as usable as possible. You know, things like optimizing memory and letting people easily interact with peripherals by running modules. And that was nice, but many times I had users coming to me and saying, I really like what you did there, very nice code, very nice project, just a single problem. It doesn't run on my target. And that didn't happen because of the project itself, but because the various peripherals that were implemented in different ways by various component vendors. And that was really frustrating. I couldn't focus on the project itself because I had to focus on making all this interface, this hardware interface, work properly. And actually this is why I applied for this job in the mbed team in the first place. I saw the announcement and I thought, okay, you are trying to basically do the same thing. I'm trying to run applications in Lua, we're trying to run applications in C++, but other than that, we're basically trying to do the same thing. Make application development as easy and as generic as possible. And as a direct consequence of that, I think you remember this slide, I don't know, yellowish box from a few slides. That was the generic code component of our SDK. So what we're considering to do right now in the future, you have at the bottom your various Cortex targets, various types, various manufacturers, it doesn't matter. You have all this generic code that is already there. And then on top of that, we are going to try to run various languages with various runtimes. So you already heard from Simon that we are already working with we are going to work actually with Freescale and Oracle to enable that for Java. I also have it on good authority that Ilua itself is going to be ported on top of this framework. And for me this is something very interesting. I think there is a lot of cool stuff that is going to happen there. And frankly, I can't wait. That's it. Now, if you have any questions, I think we have time for 1 or 2 questions, something like that.
Yeah.
Sure.
Could you say something about your debugging, online debugging? And today is printf. Okay, so I've been teaching this stuff now for a couple of years. I use Sonic tools, and printf is okay for some students, but I think we need something more, more sophisticated. So, what's your plans moving ahead?
I think.
Okay, I'll let Emilio then. He's a bit more familiar with this stuff than me.
Yeah. So. Wait.
Okay.
So you may have heard about the introduction of this new debugging standard called the CMC DAP, and that's basically the encapsulation of many SWT transactions in hit commands. So CMC DAP implementation actually allows to drive the debugging interface without actually the need to install any driver on the user machine. So we have an example that we just again published as an open source project of a Python library that is driving the CMSIS DAP debugging interface for providing a GDB server that you can immediately plug to a GDB debugger. And of course that's the first step, because once we have a server running on the user machine, then we can finally plug it to our online ID. And so, yes, that's something that we will address in the future.
So you have plans, it's a few steps to go through.
Yes, exactly.
Any timeline?
No, we don't have yet timelines.
Yeah, we weren't going to commit publicly to a timeline of this, but yeah, it's something that we're working on it because it opens up so many opportunities. And actually, one of the really interesting ones is the slide that Emilio showed earlier about the test-driven development. That's actually one of the debugging aspect. There's actually the ability to drive tests from an infrastructure into the hardware. So it's not actually not just for debugging. We want to use the same mechanism for distributed to publish tests that could be run automatically on hardware from our infrastructure as well. So yeah, it's planned, and we'll have some prototypes early next year, I suspect, that we'll let you play with.
Since you guys are into rapid prototyping, you might have a rapid prototype.
We have prototypes of it working, and there's things that we need to fix and solve or whatever. But yeah, in fact, just to give you an insight, so the guy, one of the two guys who did the original Cortex-M architecture has joined our team to work on that. So he did a lot of debug architecture on the original Cortex-M architecture. So he's joined our team to do that stuff.
I think you guys promote Kyle as an option for publishing the software using Kyle, but it's too much of it. It's not seamless. It's totally hassle.
There's a couple of other things we'll touch on later, which hopefully will make you see where we're going, not just where we are now. Yeah, but it's a really good question. So we're totally committed to doing that. I'll just give you one hint, which is it probably won't look just like a replacement for a standard debugger, because I think there's a lot of things we think that could be done to give a lot more insights to people a lot more simply, for common problems that people.
Yeah, like for the RTOS library, having some visibility into the RTOS.
Right.
Yeah,
I mean, one of the advantages. One of the advantages we got of having a more standard platform is we can make a lot of assumptions, because we know what the software is doing, and we can even push stuff into the software itself to help debugging, instrumentation and works, and lots of things there. But yeah, that's not. We'll talk more about that next year. If that's all right. Good question.
Shall we take another question? I think the person over there already his earlier.
You show a diagram of things like networking stacks, USB stacks, file systems. Are you going to explain what those actually are, what features they have, what the licensing is, are they free? Is that going to be explained later on? Yeah.
You mean this thing?
Yeah, so...
We're definitely going to touch more on components later.
Okay.
License what you have there is open source code. And about the features, it's simply too much to talk right now, but they are fully documented on our site. So by all means, just visit our library page and you'll probably get all the information you need right there.
I'm gonna just add one detail that all the code that we publish under Mbed Official is completely open source under the Apache version 2 license. And we take care of verifying that everyone that contributed to it signed our contribution agreement. So, and there you can see libraries for USB device, host, Ethernet, TCP/IP stack running on Ethernet, etc., etc. So, just going on the Mbed Official code, it's easy to get an overview of that. And actually, I think we scheduled for something 2 questions to avoid running out of time for the other presentations.
Right.
But we will have also another panel later with other questions. So write them down and we will answer.
Thank you.
Thank you.